So let us start today's class. In this class, I'm discussing about different types of recorders as well as ECG. So coming to null balance recorders, if the self-balancing action of all the null balance recorders is provided by the servo motor. In these recorders, a position type linear servo mechanism is applied to a variety of potential and bridge type circuits calibrated for various type of measurements. In the system, the input signal under the measurement is compared with the reference voltage produced by a feedback element which is accurately calibrated with respect to a mechanical position on an output display scale. The detector or servo amplifier senses the difference between the unknown and the reference voltages and actuates a motor which positions an indicator on the output display scale for a zero error or null voltage condition between the unknown and reference voltages. With the appropriate scale factor, the indicator position on the output display scale indicates the magnitude of the input signal under measurement. Null balance recorders are of the following types: potentiometric type, bridge type, linear variable differential transformer type recorders. So let us discuss about potentiometer type recorders. So potentiometric type recorders, the diagram I have shown here. The recorder of this type is basically a self-balancing potentiometer, which apart from the indication is also capable of permanently recording the values of the voltages as they are being measured. This is accomplished by a marking device fitted on the pointer under which moves a motor-driven chart for recording. A block diagram of self-balancing potentiometer, what I have shown, illustrates how a servo motor and other control devices balance the potentiometer. So in this circuit, the voltage signal under measurement is applied to one input terminal of a device that is called as error detector, and another adjustable reference voltage signal VR, it is applied to the second input terminal of the error detector. So error detector compares the two signals and gives the results at the output terminal. This output signal from the error detector is called the error signal, and it is employed to drive the servo motor. However, before the error signal is applied to the servo motor, it is first converted to an AC signal and then amplified up to a magnitude that is sufficiently large to activate the servo motor. This amplified error signal applied to the servo motor causes the motor shaft to rotate. Servo motor shaft is attached mechanically to a potentiometer slider, which acts as a variable DC reference voltage source VR. As the shaft rotates, it moves the slider of this potentiometer in such a direction that VR changes in value so that it approaches the value of input signal voltage Vin. When the DC reference voltage VR becomes equal to input signal voltage Vin, the output of the error detector becomes 0 and the servo motor stops rotating. Servo motor shaft is also attached mechanically to a pointer which indicates the degree of rotation of the shaft. When the servo motor stops rotating, the reference voltage VR is equal to the input voltage Vin. Since the value of the reference voltage is known very accurately, the position of pointer controlled by motor shaft position can be calibrated to indicate the value of the input voltage Vin directly. If the pointer has a pen or any other type of marking device connected to it and a separate motor is employed to drive a ruled paper chart under the marking device, the movement of the pointer records permanently the voltage measured with respect to time on the chart. Self-balancing potentiometer is employed for recording the input signal if it is in the form of voltage. Such voltage quantities exist as the outputs of active transducers such as thermocouples, piezoelectric crystals, photovoltaic cells, etc. That's about potentiometer type recorders. So next, coming to ultraviolet recorders, you can see here the diagram. Ultraviolet recorder can record events or physiological signals with frequencies in the range of 0 to several kilohertz. The ultraviolet recorder consists of a number of moving coils mounted in a single magnet block, and it is shown in the diagram. So next, coming to digital recording. So it uses a linear fixed array of small recording elements under which this paper moves, and this is in contrast with the conventional recorders that use a moving pen or stylus. The stylus in the digital recorder will be is a large number of fixed stylus, each one of which corresponds to one amplitude of signal to be recorded. Signals are thus reproduced as discrete values at discrete times. Analog as well as digital signals can be processed. So coming to ECG. So what is this ECG? That is the choreograph is an instrument which records the electrical activity of the heart. The electrical signals from the heart characteristically precede the normal mechanical function, and monitoring of these signals has great clinical significance. ECG provides valuable information about a wide range of cardiac disorders, such as the presence of an inactive part or an enlargement of the heart muscle. Electrocardiographs are used in catheterization laboratory, coronary care units, and for routine cardiac diagnostic applications in cardiology. Although the electric field produced by the heart can be best characterized by vector quantities, it is generally convenient to directly measure only scalar quantities, that is, a voltage difference of the order of millivolts between the given points of the body. The diagnostically useful frequency range is usually accepted as 0.05 to 150 Hertz. The amplifier and writing part should faithfully reproduce signals in this range. A good low frequency response is essential to ensure stability of the baseline. High frequency response is a compromise of several factors, such as isolation between a useful ECG signal from other signals of biological origin and limitation of direct writing pen recorders due to mass, inertia, and friction. The interference of non-biological origin can be handled by using modern differential amplifiers, which provide excellent rejection capabilities. CMRR of the order of 100 to 120 dB with 5 kilo ohm unbalance in the leads is a desirable feature of ECG machines. In addition to this, under specially adverse circumstances, it becomes necessary to include a notch filter tuned to 60 Hz to reject hum owing to power means. So the block diagram of ECG machines is illustrated in the diagram. The potential picked up by the patient electrodes are taken to the lead selector switch. In the lead selector, the electrodes are selected 2 by 2 according to the lead program. By means of capacitive coupling, the signal is connected symmetrically to the long tail pair differential preamplifier. The preamplifier is usually a 3 or 4 stage differential amplifier having a sufficiently large negative current feedback from the last stage to the first stage, giving a stabilizing effect. The amplified output signal is picked up single-ended and is supplied to the power amplifier, which is usually of the push-pull differential type. The base of one input transistor of this amplifier is driven by the pre-amplified unsymmetrical signal, whereas the base of the other is driven by the feedback signal resulting from the pen position and connected via frequency selective network. The output of the power amplifier is single-ended and fed to the pen motor, which deflects the writing arm on the paper. A direct writing recorder, usually adequate as the ECG signal of interest, has limited bandwidth. Frequency selective network is an RC network that provides necessary damping of the pen motor and is preset by the manufacturer. The auxiliary circuits provide 1 millivolt calibration signal and automatic blocking of the amplifier during a change in the position of the lead selector switch. It may include speed control circuit for the chart-driven motor. A standby operation mode is usually provided on the electro ECG. In this mode, the stylus moves in response to input signal, but the paper is stationary. This mode permits the operator to adjust the gain and baseline position controls without wasting the paper.